Okay, welcome back. Pleasure to be teaching you. This is now the question section of homework 8.2, and there were three questions, and so I've got them right here. I already wrote out some of it so we can move a little more quickly. But the first question is, how do you know which side of a right triangle is the hypotenuse? How do you know which is the adjacent? How do you know which is the opposite? We already kind of went over this in the definitions, but let's review it. So the hypotenuse is always the longest side of a right triangle. It's always the one that's opposite or across from the right angle. So the hypotenuse is fixed. It never changes. It's always the longest side opposite of the right angle, and usually it's C. This won't not be always the case, but typically the hypotenuse is C because the right angle is usually marked as C. That will change, so don't that's not set, and that's why I say usually. So that's the hypotenuse. And as I said in the last video, the adjacent and the opposite, they vary. They change depending on the reference angle. So depending on whether I'm looking from angle A or angle B, the adjacent and the opposite sides will change. So the adjacent means next to, it is the closest leg to the reference angle. So if I'm standing at angle A, then B, leg B, is the adjacent side. Again, never the hypotenuse. That is what it is. It's fixed. So if I'm at angle A is my reference angle, then B would be my adjacent. If I'm over at B, angle B, then A becomes my adjacent angle. So again, it changes depending on your reference angle. Opposite is then the other thing, that if it's across from the reference angle. So if I'm at angle A, then side A over here becomes my opposite side. Opposite A, adjacent B, all from the reference of angle A. They switch. If I switch over here from angle B, then now side B has become opposite and side A has become adjacent. Okay, so these change depending on your reference point, your reference angle. Question number 2 on the homework. In trig ratios, what quantity always goes as a ratio or written as a fraction, angles or side lengths? So when you see a trig ratio, it will always look something like this right here. Sine or cosine or tangent of some angle, I just picked sine of A in this case, equals a ratio, something to something, something over something. So you have these two key things. You have the A or B here, and you have the ratio here. Just the point of this question is to point out that whatever always goes next to sine, cosine, or tangent is the angle. Okay, and that's the second part of this question, which is always calculated with sine, cosine, or tangent. It's the angle. So the angle will always get plugged in here. These are variables. And so you'll plug in degrees. This will always be degrees until you get to radians. Congratulations. Oh, that's not how you spell degrees. There's my handwriting, so you know it's me. So the angle, this will always be an angle in degrees. The fractional part, the ratio part, will always be side lengths. So notice this is a capital letter for angles, lowercase letters for side lengths. So the next to the sine, cosine, or tangent, that's always the angle. So these will always be distance here. So just to kind of orient yourself, whenever you see a trig ratio, we'll do one down here. This is always an angle, this is always in degrees, and this is always a ratio or a fraction of distances, side lengths. Okay, question number 3 is then 4 practice problems out of the book. So we'll do one here, and I'll switch papers, and we'll do the other 3. So question number 2 out of the book asks you to draw a triangle MNP, and it says that M is the right angle, so we were able to set that up. And then it says find tangent of N. Okay, so I know you've been chanting it all day long. So, ka, toa. Write that on every piece of paper during this chapter and forevermore. So, ka, toa. So, ka, toa. Because when I say tangent, you don't want your brain to freeze up. You just go toa. Toa. So if I stand at my reference, if I'm talking about angle N, that means I'm looking from this angle, and I go toa, opposite over adjacent. Toa, opposite. So from N, then this would go on top and this would go on bottom. So they haven't given us letters. I would call this, let's go ahead and switch colors. This would be side N because it's across from angle N. This would be side M because it's across from angle M. And this would be side P because it's across from angle P. That's usually the easiest way, I believe, to name sides of a triangle. So the tangent of N would be the opposite TOA over adjacent. So that would just be N over P. That's all they're asking for that question, just making sure you can set up the ratios right. Tangent of N would be the opposite N over this leg, the adjacent leg here, P. So that's first question number 2. So once you know what you're doing, it's a pretty simple question to answer. Okay, continuing. They asked you to do question number 4 from the text as a practice. This is the same kind of question, but now they've got distances written in. They give you a triangle here, and they say find the tangent of A. Wow, I guess I gave you 2 tangent problems. All right, SOHCAHTOA, SOHCAHTOA, TOA, opposite over adjacent. So I stand at angle A, and I go, who's opposite? 3. Who's adjacent? 4. So my trig ratio from angle A is 3 over 4. Simple as that. You could write it as a decimal, but there's no reason to do that unless they specifically... Actually, I think they ask you, write it as a decimal. So 3/4, that's 0.75. Just box my answers. If you don't know your decimals, you just plug it into your calculator. 3 divided by 4, it'll give you the decimal form that you need. Okay. So pretty simple question so far again, as long as we know what we're doing. TOA from A, 3 over 4. Notice if they'd asked me angle B, it would have been the opposite, because I would have had 4 as my opposite and 3 as my adjacent. That's why this letter, the letter they give you here, matters. It changes because that's your reference angle, and it depends which angle you're talking about. Okay, here they want you to actually calculate a trig ratio, a trig ratio. Tangent of 67 degrees. This is a super difficult, I'm joking, super simple problem with your calculator. You'll need your calculator for this chapter. So all you do is you plug this into your calculator. I'm going to attempt to show you on my phone here. We'll see how well it shows up, but I'll just describe what I'm doing. Is to calculate this, that's getting a nice little glare. That means you're just going to actually hit your tangent button. Notice I've got sine, that's log. I've got cosine, tangent, sine. I've got all these options. This time I'm just going to hit tangent of, it says 67 degrees. So 67 degrees equals, notice trig ratios usually are going to be very long irrational numbers. That's why it always, in our book, it's saying round to the nearest hundredth. The hundredth is not the tenth, that's your first decimal place. Hundredth is your second decimal place. So this is going to be 2.36. 2.36. And I usually put in approximately, because we just rounded that. It's not exact. 2.36. So the tangent of 67 degrees is 2.36. Simple as that. Now, if they had, just so you know, if they'd asked for any other degree, we could do that. If they said cosine of 45 degrees, we could say cosine 45 equals, and we get that right there, 0.71. So it's very easy. When you see a problem like this, it's just a plug and play, because what you're calculating is, without even seeing the triangle, you're calculating this decimal place based on the angle. Okay, so just plug those in, and you can get and round to the nearest hundredth, and you can, those are pretty easy. Okay, so now here's a more typical trig problem where now we actually are going to use a side of a triangle. This is the whole reason we're learning SOHCAHTOA, sine, cosine, and tangent, so that we can take a right triangle, knowing an angle and a distance, we can plug them in and we can find a missing side. So in this case, it says find side BC. So they're looking at this side right here. What is this? I'm going to call this is my missing side. Now, the way I like to do it is, I'm also calling this is side A because it's across from angle A. So I'm going to call it side A. So we need to this is our variable. We need to find this using this and this. So this is a typical trig problem. Again, notice that the normal format is you have a sine, cosine, or tangent of a degree of an angle, and then you have 2 side lengths of a ratio. So let's take a look. We know angle A. We're not angle C up here. We know angle A. So standing at angle A, we need to think, does SOH, CAH, or TOA associate these two sides. This is the hard, one of the hard, just learning to set these up properly. So from angle from angle A, 23 degrees. So opposite over hypotenuse. Do I know the opposite? Or do I want the opposite? Yes. Do I have the hypotenuse? Yes. So is actually going to be the right option here. I'm going to want to use sine because it associates the opposite, the two dimensions they've given me. They haven't given me this dimension. So that's why if I said ka, would I want to use cosine? Cosine would be the adjacent side, which is this side, over hypotenuse. But since that's not even part of what they're asking me to find, I don't want to use cosine. Or TOA, tangent, it would be opposite over adjacent. Again, adjacent is not what I don't even know the adjacent. They've given me the hypotenuse. So I would not want to use tangent. So that's your first step in a problem like this, picking the right ratio to use. So I'm going to use sine. So then you set it up, sine. And again, next to that always goes the angle. So sine of 23 degrees equals opposite, that's my I don't know, A over 4 inches. So now I've got an equation. You may think, what is that? I can't do anything with that. Yes, you can. We just learned up here that I can plug this into a calculator, and this is actually a number. And so I'm going to plug this in, and then we can go from there. But let me show you, before we plug that in, let's look at how would I get A by itself. A divided by 4 is this number that we'll get on our calculator. Well, the opposite of dividing by 4 is multiplying by 4. So if I multiply both sides by 4, this is going to cancel out. And so I get sine of 23 times 4 equals A. So if I didn't have a calculator, this would be my final answer, because this is a number. A is 4 times the sine of 23. Now I do have a calculator, so we're going to go ahead and take that out right here. Hopefully we can, again, sorry if things are blurry, but you can just listen. So I can go ahead and go sine of 23, I'm going to hit equals at this point. There's my beautiful irrational number. Now I'm not going to round it at this time because I'm going to try to be as accurate as possible. I'm just going to hit times 4. 4 times the sine of 23. And so there's, again, and we're going to round that to the nearest, not tenth, but hundredth. So the answer is 1.56. So 1.56 is approximately A, or side BC. So we can see the hypotenuse, the longest side, is 4 inches. So A is 1 point, and I should actually put some units. Don't be naked in your math. Okay, or if you are, don't tell anybody about it. So if you're turning it into me, make sure you put units on it. 1.56 inches is this distance right here. And in 8.3, we'll continue this, and we'll be solving for this side, and we'll get this other angle. We'll solve everything. But in this case, you're just finding this missing side. So again, first step, we needed to pick out the right ratio that associated the two sides we wanted. Then we plugged in what we knew. We knew the angle. We knew one side. We knew the hypotenuse. We didn't know the opposite. And then we just used algebra to solve it. Multiplied by 4, and then we calculated this in our calculator, 1.56 inches. Man, can you think of anything more fun? We're going to have a good time. See you soon.